Hi everyone, David Mala here. Today we're going to do some really cool stuff. We're going to do exploratory data analysis in R, and we're going to do this on customer service reason code data, things where they had some issues, and this is data from an actual company. So let me show you the data real quick. We're going to have some really cool graphs like this one over here. So let's start with the data and see what we got here. So basically I'm going to have a couple rows of, district, store number, period, case ID, the reason code, and then what makes this a little bit more complex is this Excel sheet we're going to pull data from also has a pivot table built into it right here, and we don't want that data, but I don't want to have to delete it. I want to leave it the way it is. So I'm going to show you how to get this data without getting this data. All right, so let's get into it and start building this out. So first we're going to start off with the libraries, right? So there's three libraries you're going to put in here: dplyr, dplyr, Ggplot2, and xlsx. xlsx is very simple. We're going to use that to pull this from the Excel sheet. So let's open this up a little bit wider so you can see what I'm doing here. And so once you've loaded these in, if you don't have one, just use install.packages and then in quotation marks the name of the package. Then once you've done that, you're going to use read.xlsx, the location of the file, and then comma 1. This right here, and then we'll put that into a new data frame called data1, and so this will have that in there. Then what we want to do is we want to identify in that data the NAs. So I know that the three columns that are going to be, the pivot table are going to have below them a lot of NAs in them. So what we want to do is we want to look at data 1, right? So if we look at data 1, this is when it first comes in. You'll see that everything else is normal, and then you've got the three from the pivot table, right? These guys right here, and these two even have NA in their name. But you see down below, they're completely NAs, except for a few rows. Okay, so let's go back here and let's show you how to deal with that. So first, you can also do this. You can look at the data, which we just did, just to identify the NAs, right? You can use the str function, which is this. Use str of that, and it'll tell you in there the NAs, and you can see them right here. You can see them right here, or you can also use summary of the data, right? The summary function, and that'll tell you all the NAs at the bottom of it. See right there, 50, 51, and 50, right? So once you have determined you have NAs in there and you want to remove those actual columns that have that, what we need to do is you can drop by getting the first 8 columns and placing it in a new data frame, which is what we're going to do right here. So this line right here is we take data 1, which is the data frame we have, and then we're going to filter it down to columns 1, 2 through 8, just like that, and that will give me those columns that we want without the extra 3. Now, so when you first pull it, you got 11 columns. We're going to have 8 columns out of this one. And then I also down below, so you don't get rid of any data, you don't lose it, we can also, if we wanted that pivot table data, we call it data 1 NAs, that's what I'm calling it here. You take data 1 and then negative, the opposite of this, so negative C. So what that does is the first one gives you the first 8, the second one here gives you what's not in that first 8, which is the other 3, okay? And you can check on that here by just going over here and looking at what do we have? We have data 2 and data 1 NA. So if we go through this, what do we have here? We first come in as 57 observations of 11 variables. Data 2 gives me 8 variables, which is exactly what we want. And then we have data 1 NAs. In this case, it's 0 variables because we probably didn't run it. But it doesn't matter. I'm not going to worry about that one right now. Actually, we have it here under DF. I might have called it DF and accidentally didn't do that. So that's all we did. We did DF. And that put it in 57 observations of 3 variables, which is the other 3. Okay? So anyway, it doesn't matter. What matters the most is this part right here that you get those 8 data 2. So if we look at data 2, there it is right there. We've removed those to the right. We now have just 1, 2, 3, 4, 5, 6, 7, 8 in the correct 8 columns that we want. So next that we've done that, we want to look at the data. This is the biggest part of exploratory data analysis, is just looking at the actual data and seeing what you got here. So again, if you do the str function on it, right, you get this, and you can see that you have several rows that are numeric and others that are factors. okay, and how many levels of different types of factors they have in it. This is actually, the received date is actually a date field, but it's coming across as factor. And the other one is you have duplicate cases and invalid coupons and stuff like that. You have 5 different levels of reason codes. So next we want to do is we want to look at it and see the mean, median, min, max, etc. So to do that, we look at summary, right? The summary function, which is this right here. And if you look at this, these are your 8 columns, right? 4 and then 4. And what you can see in these is your minimum value, your first quintile or quartile, the median, the mean, the third, and then the max, right? So you've got your minimum scores in district is 1, your max 13, and in between store numbers. The most important ones are going to be, your reason code right here, these guys. All right, so next we do have one row in here that has NAs. In the summary thing, you'll see it. So even though we got rid of those 3 that had a lot of NAs, right here, if you look at this one store number, in it we have NAs. We have one row of NAs. So what we want to do is you can use the mean, but in this case it's a store number. You don't want to do that. You wouldn't want to use the mean because it would give you a non-store number. So instead we're going to just remove that row. So what we do is use the na.omit of data 2, and that will give us the data 3. I put this in a new one so we don't lose any data. Right, so I can always go back and pull data 2 or whatever. And data 3 has 56 observations of 8 variables. See the difference there? 57 versus 56. So we remove that one row. Okay. Next, what we want to do is we're going to plot a quick histogram of that. Right. I want to see quickly my data. How does it look? So first, you're going to run this PAR MF row equals C1, 1. The reason why you do that is to default to one big graph. If you have been running other things in R, you might have it set up to be 2, 2 or something else where you're showing multiple graphs and it won't show it correctly. It'll show it really small. So you run this one. Then once you've run that, we're going to create a quick histogram with the plot function, right? So it's plot of data 3, and we want to do it of the reason code field, reason.code. So let's do that right here. There it is. That's a quick, simple histogram. Shows you. Now it doesn't give you all of the labels until you open it really wide, and then when you do, it'll give you all of the labels here: product of stock, price issue, invalid coupon, employee complaint, duplicate cases, all of that. Now we don't want to leave it just like this. We want something a little bit nicer and fancier. So what I'm going to do is I'm going to show you in Ggplot. Right, so Ggplot is one of my favorite functions in R for graphing, and what we're going to do is we're going to call Ggplot, see it right here, of data 3, aesthetics, that's what AES is, that's the aesthetics, how do we want to graph it, what are the X, the Y's, and things like that. So in this case, the X is going to be reason code. We're going to fill it by reason code, so each reason code will have a different color, plus geom bar. If you don't put geom bar in there, it's not going to show anything, right? So the geom bar is how we're going to show it as bar graph, which is a histogram. Stat equals count. So I want to show the count. So let's do that. Now, doesn't that look pretty? We've got some nice colors there. Let's open this up a little bit. Bring it over this way so you can see it a little bit better. There we go. It's got the reason codes down below. Obviously, price issue and product out of stock are the biggest ones. And it tells you, in this graph or this legend over here, which is which by color. Now, it doesn't have a title. It doesn't have anything else to it. So that's just a basic, simple Ggplot bar chart. We can make this better, right? Obviously, you know that, so we're going to do that. So let's take this. If you take this Ggplot, this is exactly what we had in the line above. Now we're going to add this stuff. Oh, let's go off the chart here. We're going to add theme minimal and Gg title, which is going to be 2019 customer complaint reason codes. Geom text, where stat equals count, because that's going to give us the count of each of these. So we know exactly, even though we know it's 30, or above 30 for the price issue, we don't know, is it 37, is it 36, is it 38? This will give you the exact amount by using stat equals count, aesthetics label equals count, and then vjust equals 2 is going to be where the vertical adjust is going to be. And then we also want to have the labels of reason code and households. For X lab is the X label, Y lab is the Y label, right? So if I take this whole thing and you're going to put it into G2, oops, let's do this correctly. Let's see if we can get that all in there. There we go. And hit enter. You'll get this, which looks a whole lot better. See that? And then if I bring this over this way, and I bring this up here, look at that. Now it says 2019 customer complaint reason codes. Reason codes are over here. Households is over here. Reason codes is over here. And we even have numbers on the bars to tell you. So see, it's 37, 12, 2, 4, and 1. It looks very nice, very pretty. Very nice to show how our data is there with these reason codes. Now let's look at a little bit more. So now what if we want to look at it with the table function, right? So if I take table of that same column, right? So data3 $ reason.code. Remember, $ is to get that exact column, right? And we run that. That gives me this, right? It gives me the breakdown exactly what we just saw here, 37, 12, 2, 4, 1. It's just a different way of looking at it. And again, the str function will give you some of the sample data in there so you can see that. Okay. Now, if we go beyond that, let's look at the correlation. Let's just see, are there any columns here, duplicate cases, price issue, or outside of the reason codes, any of the other columns that we need to bring into consideration here. So what we want to do is we want to do this with the dplyr function. Select if data3 is numeric, right? Because we can only do this with numeric. You cannot get correlations on the factor fields, right? So you have to do this. So we will do that. And then what we want to do is the correlation COR of that new data field. See, I call this data3 numeric. Okay, so I want to put that here. So if I run this, right, and I'm going to put that data3 core, but let's just run this. The standard deviation is 0 in this case, okay, and let's put that in here. And then what we do is you round it to 2 decimal places, okay, because you don't want these big long numbers like this. So you use this right here, which is round data3 core to the 2nd place, okay. And if you look at that, now you've got this district. So this is the correlations with 2 digits, right? Because we did that, we could have made it 3 digits. That's fine if you got too many of them that are close. And if you look at this, when we're looking at this, you have the ones that show any correlation, or if it's closer to 1 or closer to -1, right? So -1 would be a negative correlation. So as 1 goes up, 1 goes down. Positive correlation would be closer to 1, where they both go up, right? So the only things that really have a positive correlation here would be your week number and period. Right, it's 0.94. So number, very weak correlation with weak number at 0.48. It's meaningless. You might be able to split out maybe or aggregate based on weak number if you wanted to, but we're not going to do that in this case, okay? So next, let's do a line graph. Let's look for trending, right? So I want to look at trending, and instead of so the bar graph looked at just the breakout of these, but it's not over time, right? Now I want to look at a time component. So we have week number, we have year. So what we're going to do is a simple line graph with Ggplot, right? So like earlier, except that we're going to use Ggplot, and instead of putting it inside of this Ggplot, we're going to use this plus geom_line aesthetics. Now this time, because we're going to do a line graph, we need both an X and a Y. So you got reason code, and our X is going to be our time frame, which is week number. And then we want to colorize it based on reason code. You don't have to do that, but I want to do that, so it breaks them out differently. And then size equals 0.8, and data equals data3. Data3 is not data core. Remember, this is data3 numeric, and data core was for the correlations. We're not going to use that here. We use data3. So data3, let's just do this, right? And give it a second. There it is. So now let's bring it up a little bigger. Now this is not going to be your typical line graph where you go up and down. So we want it broken out by each of these different reason codes, okay? Which is what we're doing here. So you can see here, product out of stock. This gives you by week number. So you can see, like for instance, invalid coupon only happens in week 52 or so at the end of the year. Employee complaints really only happens around week 47 and 48. Versus these are all year round, and there's very few duplicate cases. Okay, so from that you can get an idea of, you know, focusing on, well, this one is holiday time, you know, or something like that. But let's do a better graph. Let's take that and take it up a notch. So we're going to do this Ggplot, geom_line, week number, same thing. This is all the same as what you saw above with the plus at the end. Remember, pluses go at the end. for the next line. Theme minimal, we're going to put a title on it of 2019 customer complaint reason codes. We're going to put the same things we did above for the box graph or the histogram, and we're going to do label equals count, vjust equals 2, and then the same thing to get the xlab and ylab, which is your x labels and y labels. So let's run that. Okay, give it a second here. There it is. And so now you have the same graph, but it's a lot prettier in that it's got a title on top, it's got the correct labels on the sides, and you've got the reason codes here. You can clearly see what's going on there. But let's take this to another level. Let's look at some other things. Because remember, we're doing exploratory data analysis here. We're going to look into this data and see all the pieces that are interesting here that we could dive further into. So next I want to do a box plot. Now a box plot is the one I showed you at the very beginning. So what we're going to do is we're going to take the plot function, right, and we're going to do it by reason code and week number. So when you use the plot function, you have data 3 $sign in the column, reason code and week number, right? Type equals L, right? And column equals green. Let's see what that does, right? So let's take this, and there you go. Look at that. Now that's, if you like it that way, that's fine. It's a very standard box plot, but you don't have titles and things like that on there. Now if I open up bigger, let's get it even bigger, it'll start to show all of the labels down below. When it's shorter, it won't necessarily give you that. So that doesn't mean they were missing. It's just that when it's smaller like this, you don't see all the labels. They can't fit in there. So if we take the same one and we do this to it, what we're going to do is same thing for the top. This whole line is the same, then comma, right, except for that end parenthesis there. Then you put LWD equals 4, so that's your width, right, of your lines. You're going to put X label and Y label, in this case reason codes and concentration by week number. And then main, which is your title, equals 2019 customer service reason codes. The biggest change you're going to see here is the titles, the labels on the side, or the X and Y labels, and then you're going to have a different width to the line. I'm just going to make it look kind of cool. So let's just do that. See the difference now? Now you've got, it's a nice looking graph. It almost looks like it's hand printed a little bit, this with that kind of a width to it. It does make it stand out a little more. You don't have to do that. We could have done LWD equals 1, which would have been what the first one was. It's up to you if you want that. Helps. I think this helps clarify things. And what's really neat with the box plot is it shows you the distribution of these numbers and where the means are. So for instance, in this one right here, the mean is in this black area right here, but the distribution is all the way to here, but then there's the vast majority of it there. But then there's also some here, and then there's outliers. Same with here, there's a long distribution of it, but the main part is here and the mean is right here. See that? So if you look at this, the first ones didn't tell you this, but this one right here tells you that this one is all at week 52. This one is close, is at week 52 and before, right before. This one is close, and this one is close. So a lot of the activity actually happens around week 52, which is holiday time, Christmas season. But you also have this one down here. It's a little bit off and different. If we wanted to open this up to see, remember, you have to open up to see all the complaints. You could take it this way, and then we could open it this way. And what that does, it shows me this one here has got some outliers at week 48. Okay, and around week 47 and 48, and mostly around week 47. We'd want to look at why was there employee complaints this period. Not sure, but it's something they would definitely want to look into. And then obviously at Christmas time, there's a price issue, product out of stock. So maybe because the stock was lower, the price was higher. Could be something we couldn't couldn't have accounted for. Maybe the price went up because of the holidays of a number of items. Invalid coupons, people get mad and upset. There's probably a higher number of coupons that area or time frame, and then duplicate cases that would just go along with the other things of people putting in, they put in a complaint and then they put in a similar complaint, within very small time frame. So that's just people are highly upset. They're probably trying to get something for Christmas time and couldn't get it. It was out of stock. It was a price issue, whatever it was, and these all have data in that range. Okay, so this one could be any of these as duplicate complaints. So let's go down here. So you've seen all the code, and basically let's just look at a quick summary of this. So this is what you always want to do, is you want to summarize this what you've done. You've got some great graphs here to show to people and say, here's what I have at the exploratory data analysis piece of this process or this data that I'm looking at. Okay, what we've done is we've cleaned the data, we've cleansed it by removing 3 rows of the NA columns, right? Because they gave us an Excel sheet with a pivot table. So I've shown you how to get rid of those 3 rows of the pivot table that we don't need that data in here. I've also shown you how we explore it, how we get the mean, median, and more with the star function, which is important to have that so you can see the breakouts, but I show you other ways to do it too, like here, okay? And these graphs give more meaning to that. Next, we looked for correlations and did a bar chart to see, what was the makeout of the reason codes, which ones were the biggest problem, which ones, so on and so forth. And then we looked at a line graph and a box plot to see if we could identify any further possible trending over time. From this, we can see that the price and out of stock issues, which are these guys, okay, were our most common customer service issues. And as I said earlier, most of the issues tended to occur between weeks 49 and 52, right in here, which is, holidays and Christmas time. So basically, this is how you would do an exploratory data analysis, and then from this, you could go further. You could go into delving into, certain parts of the data and saying, okay, let's go and do an analysis based on, the time trend, or compare this to another data set. You could do all kinds of stuff, but that's what you do in exploratory data analysis. I'm glad you watched this. I hope you had fun and learned a lot from this. Please take a moment to subscribe, like, and share, and be sure and click that bell down below so that you get notified every time I put out a great video like this. Thanks again, and have a great day.